tutorial. Today we're going to talk about ellipse. Alright, so what is an ellipse? So basically an ellipse is a set of all points. So a set of all points, the sum of whose distances, so of whose distance from two fixed points is a constant. So these two fixed points that we are talking about is called they are called the foci. That's the plural form. So we have the focus. Each of them is called the focus. Then the plural form is the foci. The line containing the foci intersects the ellipse at a point called the vertex. So I'll draw a diagram for you to visualize how it is, how an ellipse look like. All right, the line segment between the vertices is called the major axis, and its midpoint is the center of the ellipse. All right, so let me quickly draw a diagram on that for you to see what an ellipse is. Okay, so with this, now the distance, this one focus and another one focus. So let's say 1 and what 2. Now we are saying that each of them is called what, the focus, and the plural form is what, the foci. And also the line containing the foci intersect the ellipse at point called the vertex. Now this line is intersecting this ellipse at this point here and also at this point here. So at this point is called the vertex, also the same way here. So in the plural form we what, vertices. Alright, and also the line segment between the vertices is called the major axis. So this line from here to here is called what, the major axis. It's called the major axis. Then also its midpoint is the center of the ellipse. Now this is the center, so it means that the distance from this place to this place is the same as from this place to this place. All right, a line perpendicular to the major axis through the center intercept the ellipse at point called the co-vertex. So this line here is what, perpendicular to what, the major axis, and it intersects the ellipse at a point, and those points we got what, the co-vertex. So this is a co-vertex, this is also another co-vertex. All right, now the distance or the line segment between these co-vertices is called the minor axis. All right, so basically we are saying that an ellipse is a set of all points, the sum of whose distance from two fixed points is a constant. So let's use this definition to derive the equation of the ellipse. Equation of the ellipse. Okay. So equation of an ellipse. Okay, now let's consider this ellipse here. Okay, so this our first, we have focus 2 with coordinate negative c0. So this is at the negative side of the x-axis. Then we have another one here with c0 because at the positive side. Now the vertices, the major or the vertices here, the vertex, let's name it a0, and this at the negative side we have negative a0. Then we have the co-vertices 0b, then also 0 negative b. All right, now let's take any point on the ellipse. Let's say point P with coordinate x, y. The distance from this point to this point, and also the distance from P to what? B here. So let's name this vertex A and this is what? B. Okay, so let's see. Now the distance from this point to this point, so let's say this is A, this is also A, from here to here, then from here to here. So it means that the whole of that point is what? 2A. Now this is also B, B. So the whole of this will be what? 2B. Alright. So from the definition of this ellipse, we said that an ellipse is what? A set of all points, the sum of whose distance from two fixed points is a constant. So let's see. So from here, the distance from F1 to P plus, so the sum, the distance from F2 to P is the same as the distance from F1 to B plus F2 to B. Now this F1B and F2B, it is going to be that constant that we are talking about, which is what? Our 2A. So how do we get that 2A? Let's derive something here. Now the distance between this point, between the F1B, so F1B will be equal to the square root of A minus C all squared. So we have F1 here, then the B here, we have A minus what? C. Then we have 0 minus 0, so I'm still getting this here. And this is going to give us what? A minus C. That's for the F1B. And let's see F2B. This one will be equal to the square root of A1 or A plus C squared. Then the rest, you see that you are going to get 0, 0. So minus 0 still, this is going to give us what? A plus C. Now we said that this plus this. So it means we are going to get A minus C plus A plus C. And this is gone. So we have A plus A, which is going to be 2A. So basically we can write all of this equating it to what? 2a. And this one is the constant that we are talking about from the definition of the ellipse. All right, so let's see. Let's continue with it. Now we know that f1p plus f2p will be equal to what? The constant 2a. We equal to what? 2a. Now, what is the distance between the point f1 and p? What will you get from there? So let's try to do that one too. Okay, so in this case, we're going to get square root of x minus c all squared plus y minus 0 all squared, then plus the square root of, so the second part, we get x plus c all squared plus y minus 0 all squared. Then this is equal to what? 2a. All right, so from here it is f1p to f1p. So I'm going to get x minus c. You see, x minus c, then y minus what? 0. That's what we have there here. See it? Now with the f2p, x minus negative c, then we turn to what? Positive. So we have x plus c, then y minus 0. That's what we have there. Okay. Now let's try to bring the whole of this to the other side of the equal sign. So now we have root of x minus c squared plus y squared being equal to what? We have 2a minus square root of x plus c squared plus y squared. So let me rewrite this. I have square root of x minus c all squared plus y squared being equal to 2a minus root of x plus c all squared plus y squared. So we are trying to derive the equation of an ellipse. Now at this point, let's square both sides to get rid of the square root. When we square, so square both sides. If you square both sides, this side will go, so we have the square root here will go. So we have x minus c squared plus y squared being equal to, now this, the whole of this squared. So what happens? So we are going to get 4a squared minus 4a root of x plus c squared plus y squared, then plus x plus c squared plus y squared. That's for the other side. Now at this point, we can expand this, and this is going to give us what? X squared minus 2xc plus c squared plus y squared. Then we have 4a squared minus 4a root of x plus c all squared plus y squared. Then we can expand this. We have x squared plus 2xc plus c squared plus y squared. Now looking at this, this will go with this, and this will go with this, and this will go with this. So at this point we have negative 2xc. Okay, then being equal to 4a squared minus 4a root of x plus c all squared plus y squared, then plus 2xc. Okay, so let's see what happens next. Now at this point, we can decide to bring the whole of this to this side. Then we have 4a root of x plus c all squared plus y squared, then being equal to 4a squared plus 2xc. This will cross, we have plus 2xc. Now we have 4a root of x plus c all squared plus y squared being equal to 4a squared plus 4xc. Now to make it simple for us, we can divide through by what? So dividing by what? 4 to make it simple for us. So this is going to give us what? A root of x plus c all squared plus y squared equal to a squared plus what? xc. Alright. Now still we have our square root there. So let's square again. So we square both sides again. If you square both sides again, what are we going to get? So this side will give us what? A squared multiplying. So you see this is going, so we have x plus c all squared plus y squared being equal to, we square both sides, so this is going to be affected too. So we have a exponent 4 plus, so we are squaring both sides. So this how we're going to get that one. So 2xa squared c plus x squared plus c squared. Okay, so we can expand this here. So we have a out, x squared plus 2xc plus c squared plus y squared being equal to a exponent 4 plus 2xa squared c plus x squared c squared. Now let's see, we can multiply through by what? So this is a squared by a squared. We have a squared x squared plus 2a squared xc plus a squared c squared plus a squared y squared being equal to a exponent 4 plus 2xa squared c plus x squared c squared. Now this and this is gone. So let's see what happens next. So we are left with a exponent 2x squared plus a squared c squared plus a squared y squared being equal to a exponent 4 plus x squared c squared. Alright, so let's see what next to do. Let's send this one to the side and this to the side, and let's see what happens. We have a squared x squared minus x squared c squared being equal to, so plus the a squared y squared being equal to a exponent 4 minus a squared c squared. Now the common one here is what? X squared out. We have a squared minus c squared plus a squared y squared being equal to, the common one is a squared minus c squared. Now at this point, let's do something here. Let's b squared be equal to a squared minus c squared. So what happens if b squared is that? Then now we have s squared b squared plus a squared y squared being equal to a squared b squared. Now let's divide 2 by a squared b squared to make this side 1. So a squared b squared, a squared b squared, a squared b squared, and it gives x squared divided by a squared plus y squared divided by what? B squared being equal to 1. So generally this is what? The equation of what? An ellipse. This is the equation of an ellipse. This is the equation of an ellipse. Now in this case, our A with this type, when you have this one here in this form, when it's in this form, this is an horizontal what? Ellipse. So it means that the major axis lies on the x axis. So the major axis lies on the x axis. When it is in the other form, so we talk about that one very soon. Okay, so let's see how it is to deduce the vertices of that type of what? An ellipse. So generally that's the equation of what? The ellipse. This one, it is x squared on a squared plus y squared on what? B squared being equal to 1. And this forms the horizontal ellipse, which means the ellipse, it lies on what? The horizontal axis. It lies on the horizontal axis. Now when it lies on the horizontal axis, how do we determine our vertices, the co-vertices? So it is in this form. Our focus or our foci will be, we have C0, we have negative C0. Then we have the vertices being A0 and we have negative A0. The co-vertices, we have 0B, then we have 0 negative B. So in this case, when it comes to this type of the ellipse, when it lies on the horizontal axis, our vertex will be, what? Plus or minus A0. Then our co-vertex will be 0 plus or minus B. Then the foci, since it lies on the horizontal axis, means that our focus, the two focus will lie on what? The horizontal axis. So it means that we're going to get plus or minus what? C0. Yes, if it is in that form, that is that. Always A should be greater than what? A should be greater than B. So looking at this, so if it changes, so let's compare it to the vertical one. So let's look at the vertical axis. the vertical ellipse, sorry. So for that one, it lies on what? The vertical axis like this. We have our focus here and another focus here. Now our vertices are here and the co-vertices will lie on the horizontal axis. So in this case, we have our vertices being 0, negative E, and we have 0, E. Then we have B, 0. Then we have negative B, 0. So the vertices, the focus will be what? 0, C, and we have 0, negative C. So when it opens like this, the equation is in the form, x squared on b squared plus y squared on what? A squared being equal to what? 1. And c should be equal to a squared minus b squared. Now, so in this case, looking at the diagram, you can see clearly that when it's the vertical ellipse, we have our vertices being what? 0 plus or minus a. Then we have our co-vertex or vertex being plus or minus b 0. Yes. Then our focus or our foci will be 0 plus or minus what? C, because it lies on the y axis, and that is that. Okay, so when it's given in this form, note that A is greater than B, so we should consider that one too. All right, so let's take an example on that and see how we are gonna solve that type. Okay, the first question says that so determine the coordinate of the vertices and foci, hence graph the ellipse. So we are going to determine the focus and the vertices, then also what? Graph it. Now the ellipse is x squared on 16 plus y squared on 9 equal to 1. Now you can see clearly that this ellipse is in the form x squared on what? A squared plus y squared on what? B squared being equal to what? 1. Since we are saying that A should be equal, A should what? Be greater than what? A should be greater than B. So it means that it is in this form. So when it's in this form, it means that it is an horizontal what? Ellipse. Now by comparison, our A squared will be equal to what? 16. So we have root of this, then our A will be what? Our A is 4. Now then our B, so our B squared will be equal to what? 9. Root of this, our B is equal to what? 3. Now in this case, we said that C squared should be equal to what? We said that C squared should be equal to a squared minus b squared. So c squared, we got a squared is what? 16 minus 9. So we have c squared being equal to what? This is going to give us what? This is going to give us what? 7. Then we have 7. So our c will go to root of 7. Root of 7. Now we said that if it is an horizontal ellipse, and you can see clearly that this is an horizontal ellipse. So in this case, our vertices will be what? Plus or minus a 0. Then the co-vertex we have 0 plus or minus b. Then we have the foci being, it lies on what? The horizontal, so it is going to be plus or minus c0. So what is it going to be? Now this is going to be, the vertex will be what? Plus or minus a is what? A is 4. Then we have 0. Then our co-vertex will be what? 0 plus or minus the b is there, which is what? 3. Then we have a foci being plus or minus root of 7, 0. And that is that. So to graph this with the help of this, now when it's in this form, always remember that when it's in this form, it means that the center is at what? The origin. It is at what? The origin. So it means that we draw a Cartesian plane, our center will be at what? The origin. Now with this coordinate, we can easily graph our what? So this is the same as the vertex. This is the same as 4, 0, and also what? Negative 4, 0. Then we have the second one, the co-vertex. We have 0, 3, and also what? 0, negative 3. Then the last one we have this is the same as root 7, 0, and also what? Negative root 7, 0. Okay, so how do we graph this? So let's draw we are saying that the center is at the origin. Now 1, 2, 3, 4. 1, 2, 3, 4. Now the vertex we have 4, 0. So 4, 0. 1 is here, negative 4, 0. 1 is also here. 1, 2, 3, 4. 1 is also here. Then we have the co-vertex 1, 2, 3. 1, 2, 3. So negative 3, positive 3. So this is how it is going to look like. So you see, when you draw it, you can see that it is a horizontal ellipse. Then in this case, we need to locate our the root 7, our focus. Now it is both positive and negative, and approximately will be around 2.65. So let's say 1, 2 point. So 1 will be here, 1, 2. So 1 also will be here. We have 2 here, have another 1 here. So our focus will be here. We have negative root 7, 0, then root 7, 0. So that is that. So it's quite simple when you get all these things. Okay, so thank you for watching this video.